Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
So I created this DLL function in Visual C++ that just writes a string to a file, and every time it's called it'll append another string to the file with a new line separator. And called the function writeString. In our C++ Builder project, I want to call this function upon user input, so I already have this edit box with the text that the user can edit, and then I have a button, so I'll double click that to create a button click event handler, and upon calling that we're going to call that writeString, which is a C function, so it's in that namespace escape sequence : so we're calling writeString, and then we're going to pass it the edit values text. Now this is a Unicode string. It's a multi-byte character set, and we need to convert that to that single byte character typical ASCII C string. So if you just call CSTR on this, you're going to get a compile error. So we get this error down here about converting a wide char to a const char star. What's that? There's a UTF-8. I want to get a Unicode to UTF-8. So instead, let's create an array. Unicode to UTF-8. So the destination is stir. Source is going to be this guy. The max bytes is going to be the size of stir. Let's try running it with the debugger. There we go. Step over that function. Look at stir. Hey, looks good. So now that should run. Okay, so file does not exist. Click our button. Now it's there. Click the button. It's there. Every time I click that button, it's going to keep adding to the file. So all we're doing is passing that string, and if I change the text to something else, there. So I'm passing the string to the DLL, and it's writing it to the file. This conversion to single byte characters using UTF-8 encoding, you may not need that if your DLL's function accepts multi-byte characters using the same number of characters per, I think wide characters usually 2, so UTF-16 characters, then that would work okay. But this conversion looks like it's necessary for the single byte characters that are expected by traditional C functions.
Some details about sharing strings between modules. Traditionally, C strings are null terminated. However, that may not always be the case. Sometimes a length parameter or a length data is also passed around, and the string may not be null terminated. Additionally, the size of that null terminator may not always be exactly 8 bits, but typically is the size of the characters used in the string. The character size, or the bit width, of the encoding used by default may be an issue to deal with. The traditional character, or char, usually represents a single ASCII character in 8 bits. However, a character pointer may point to an ASCII or a UTF-8 string. UTF-8 characters are represented by one or more chars or bytes. A wchar_t is implementation defined, but typically 16 bits on Windows and may be up to 32-bit on other platforms. On Windows, it may take multiple wcharts to represent some characters. The size of the Windows.h defined tchar, or _tchar, varies based on the predefinition of the Unicode preprocessor macro. By default, when using the command line compiler, the size of a tchar is 8 bits, but when Unicode is defined, it's 16 bits. In the Visual C++ and C++ Builder IDEs, the project settings default to enabling Unicode support and a wide tchar, so 16 bits. When Unicode support is enabled in both environments, most characters are represented by a 16-bit wchar_t. Also, the wide variant of the Win32 API functions will be used by default, so a message box, for example, will point to a message box W. The default IDE behavior may be overridden via project settings or command line options. The default behavior of the Visual C++ command line compiler is to use single byte encoding with 8-bit characters, and the A or ANSI variant of the Win32 API functions by default. So an invocation of MessageBox would actually invoke MessageBox A. When combining modules that are built in different environments, you may have to deal with the differing string types by providing explicit conversion between them.
In that example, we're passing a string. In this case, we happen to be converting from multi-byte characters to single-byte characters for the format of the string, but we're passing that string to the DLL, and the DLL is writing to a file. The same would work in the inverse if you wanted to, say, query a DLL for a string, and then the application writes to a file. No problem. You're just passing really the string back and forth. Let's say you had the file open in the DLL, and you wanted to write directly to that file in the application. Could you do that? Let's try that. Let's say we have a function called openFile, and you pass it a file name, and it just returns the result of fopen, which is a standard C function. And we'll go ahead and keep opening it for append. That's fine. So openFile, and it's going to be a fname, and then it's going to return a file pointer. We need to include standard I/O to get that type. Okay, we got a warning about fopen being unsafe, and then everything succeeded. So now, rather than calling write file, we're going to call that open file. So we call file pointer fp equals : open file. And this standard functions to write to a file are like fprintf. I also have fwrite, fputs, functions like that, but I'll use fprintf. Stir. And then, so write to it, and then we'll close it. Seems like a logical sequence of events. Oh, didn't update my import library. There we go. Okay, and then let's run it. The file name is still going to be output.txt, and it's going to append, but let's go ahead and look at this file first. So it's already got something in there, so let's go ahead and delete that, just so we know we're writing new data. Click that. Oh, and we get an access violation. Let's see if find out where this happened. Yeah, so it crashed in the Visual C code. Unless you're really good at reading assembler or machine instructions, machine code, you're not going to probably make a whole lot of sense of that. We could reproduce this crash and then capture it with the Visual Studio debugger, but I actually know exactly what's happening here. A file pointer cannot be passed between a DLL and an application and reused. This pointer is going to point to some memory in the C runtime library, which is linked with the DLL, and this fprintf is part of the C runtime library of the application. And they're two different C runtime libraries, two different instances. They have different ideas of what a file stream looks like, the type, and the memory where they're storing that data is completely separate. So yeah, this is not expected to work, and that's what the kind of result you would see. Int fd for file descriptor, And then we will use write. I think has fd test. Actually, because we're going to have to do the carriage turn as well. And then for good measure, we'll close it. There's no error checking or anything going on here, but if that's the correct usage of write. Write is a standard C function. Might need to include some more headers here, but first let's change open file here to instead return an integer. File descriptors are integers. We use open create. If it has to create it, then you get si read word with si write. Permissions. Int. Actually, no longer need standard IO. I do need some. So I think it's like fcntl.h and io.h. So all it does is create this file. Okay. Make sure our import library is up to date. And then try this out. Do we actually have a text file? We do. Let's delete that. We have errors. No member called write in the global namespace. Might be fcntl.h. Control F9 for compile. No member. So io.h. Woohoo! All right. So let's run it. The button. Oh, there's no text in the file. So it definitely opened it, or created it and opened it. The write fails. Okay, what's the file descriptor value? 4. That looks like a valid file descriptor number. The -1 would be an error. 0 is like standard inputs. 1, I think, is standard output. 2 is standard error. I don't remember what 3 or 4. Anyway, but 4 looks perfectly normal, expected. Let's see, run, step over, and the debugger should tell me what the return value of that was. Here, this way we can look at result. Okay, so we're going to step over and store the result. The result is -1, so the write failed. That should be good. What's error now? Okay. So we try the write, we step over, we look at the error no, it tells us 6. Let's look at error no to find out what 6 means. Include Windows C runtime library errno.h. Bad file number. Okay, so maybe you can't do that. So let's write to it. From the DLL. Then we look at it. Oh, DLL is able to write to it, but yep, this application is not able to write to it. So you cannot share file pointers, you cannot share file descriptors. There's also the Win32 API, create file, returns a file handle. So let's try going that approach. It returns a handle. Yeah, so let's look at create file. All right. So the desired access is generic right. So share mode. Click create always. And null. I can write to the file with write file. And then we're going to return the handle. Create file A for ANSI. Yeah, he's going to say handle H. Open file. And then we should be able to do the same. Let's try that close file close operation. Close handle. Now I'm not actually going to write to it when I click the button from the application. It's the DLL should write to it though. Okay. Click it again. Okay, it's recreating it every time though, so let me close that. Delete that file. It's not there. Just run this again just to confirm. File's not there. Click the button. File's there. It says DLL, so that's good. So we know we're successfully opening the file using the handle to write to it. So let's try doing the same write operation on the handle from the application. So the DLL will write the letters DLL with a line feed, and the application will write EXE with a line feed. There we go. To complete this example, rather than writing the static string EXE with a line feed, let's go ahead and write the actual string that's in this edit box. There's no line feed here. If we want to add that, we could modify the string before we convert it to UTF-8. Say string uster. This might need to be Unicode string. Unicode string. And then change this. So that'll give us the line feed at the end before we convert it to UTF-8. Let's go ahead and run this again. And look at the file. So currently has DLL and EXE in it. And again, now we see test. The DLL writes the string DLL when it opens the file. So we'll change this to seems to work. So that's a little bit more interesting, passing a dynamic string context rather than a static string. So we can share Windows file handles between DLLs and applications. And it should not matter which entity opened the file or which entity closes the file, and they can both write to it. Of course, if you have threads or any other concurrency, that could be an issue, but at least sharing the file handle is not a problem.
To review, files opened in the DLL cannot be accessed or closed in the application, and the reverse. If the file is open in the application, it cannot be accessed or closed in the DLL. This is true for all the standard C file opening and access functions like fopen and open, and also true of any C++ methods like IOStream objects, the Microsoft MFC cfile object, or the Embarcadero tFileStream object. The one exception, however, is files opened using the Win32 API functions OpenFile and CreateFile are shareable between DLLs and EXEs.